Let me be honest with you. When I see a headline claiming an 800-mile electric vehicle, powered by a revolutionary solid-state battery, I don't get excited anymore. I get skeptical. Why? Because we've been hearing the same promise for nearly a decade. Back in 2018, when this channel first talked about solid-state batteries, I confidently said we might see them in the real world by 2020. Well, 2020 arrived with a global pandemic, and solid-state batteries arrived with absolutely nothing. Since then, every month, a new company has announced, our solid-state battery is just a few months from production. And here we are in late 2025, with none of those promises becoming reality. But the race is still alive and hotter than ever. China, South Korea, Europe, Japan, and the US are all making serious moves. Even Toyota, after years of doubting batteries and chasing hydrogen fantasies, is suddenly acting like the hero entering the arena in shining armor. So today we're going to break down who is truly closest, which claims are real, which are marketing fluff, and when we might finally buy an electric vehicle with a real solid-state battery. Before we dive in, a quick reminder. About 40% of viewers here watch the videos but still aren't subscribed. This entire channel is run by one person, researching, writing, editing, animating, and producing everything you see. So if you enjoy the content and want to help the channel grow, please consider subscribing. It genuinely makes a huge difference. Alright, let's get into the real story. We all know the pitch. Solid-state batteries are the next big thing. They promise higher range, faster charging, no fire risk, lower weight, longer lifespan. And the reason is simple. Instead of using a flammable liquid or gel electrolyte like modern lithium-ion batteries, solid-state batteries use a solid electrolyte. That solid material saves space, increases energy density, improves safety, eliminates liquid leakage, reduces the chance of thermal runaway. On paper, it looks like the perfect battery, but there's a catch. Actually, several. The transition from a laboratory prototype to full gigawatt-hour mass production has been far more difficult than anyone expected. New materials, strange chemistries, low yields, high failure rates, expensive manufacturing equipment. It's the classic obstacle researchers call the Valley of Death, and most companies are still trying to climb out of it. Let's begin with Volkswagen and their two major partners, QuantumScape in the US and Gotion in China. In October 2025, Gotion announced that its all-solid-state GeneSure battery had entered pilot-scale production. Not a lab sample, not a PowerPoint slide, actual pilot production. They claim 350 Wh/kg at the cell level, a battery pack capable of 1,000 miles. Stability from -20 degrees Celsius to 85 degrees Celsius. A lifespan of over 1 million kilometers. Their roadmap suggests small-scale integration, 2027. Mass production, 2030. And yes, you'll want to remember that year, 2027. It's going to come up again. A lot. QuantumScape, USA. If you've followed batteries for a while, you know QuantumScape's reputation. Big claims, big delays, big hype, but also real scientific progress. QuantumScape is pursuing a lithium metal, anode-free design. Instead of building an anode, they let the anode form itself inside the battery during charging. They use a ceramic separator that conducts lithium ions extremely well, blocks dendrite growth. Their latest claims, just over 300 Wh/kg at the cell level, charging from 10% to 80% in 15 minutes, longer cycle life, higher safety levels. In late 2025, they shipped their QSE-5B1 samples, and they're now installing a highly automated Cobra production system, supposedly 25 times more efficient than before. And then there's that surprising headline, QuantumScape cells appearing inside a Volkswagen Ducati electric motorcycle. That's a big deal. It means the tech is leaving the lab and entering real-world environments. Their commercial target? You guessed it, 2027. Now let's talk about the two most dominant battery manufacturers in the world, CATL and BYD. These two companies practically own the global battery market, and both are working aggressively on solid-state. CATL. CATL has been developing solid-state tech since 2016, with more than 1,000 researchers currently on the project. They have produced small lab-scale cells with 500 Wh/kg energy density, promising performance. But these are prototypes, not production-ready cells. CATL admits they are only at technology readiness level 4, and they are very clear. Charging speed, cycle life, yield, cost, and scaling still need major breakthroughs. Their target for production readiness? Once again, 2027. BYD is in nearly the same situation. They've achieved 400 Wh/kg in prototype form, a small pre-production line, basic integration tests. Their roadmap, demo vehicle, 2027, full commercial production, 2030. The main challenge for BYD isn't the chemistry, it's cost. Their LFP and sodium-ion batteries are already so cheap and so stable that solid-state must be exceptional to justify replacing them. Still, never underestimate BYD. When they set a goal, they usually hit it. Now let's talk about Chery, the brand making the boldest claim so far. In late 2024, Chery announced that they were building a gigawatt-hour scale solid-state production line. In early 2025, the first batch of engineering samples rolled out, around 300 Wh/kg. Then came the shocker, a prototype boasting 600 Wh/kg energy density, enough for over 800 miles of real-world range. That number exploded across Chinese media. But there's a catch. The 600 Wh/kg version is not a commercial product. Not by a long shot. It's an advanced prototype, and Chery fully admits that. Their target for true mass deployment? You already know it, 2027. The fourth company aiming for the same year. Some companies, especially NIO, have recently hyped their semi-solid-state batteries. NIO's ET7 sedan achieved over 650 miles using cells from Lion. But here's the truth. The battery was 150 kilowatt-hours, far bigger than most EV packs. These cells are not fully solid-state. They still use a gel electrolyte. Semi-solid batteries try to solve the interface challenge. Solid versus solid contact is hard, so they add gel to fill microscopic gaps. But that brings problems. Higher cost, dual-phase manufacturing, dry plus wet, complex sealing, more quality control, specialized filling equipment. Semi-solid is a stepping stone, not the final destination. When real all-solid-state cells arrive, the semi-solid approach likely disappears. We can't go through every single company, but a few are worth highlighting. Ferasis, China, backed by Mercedes-Benz. Pilot line running. Gen 4 pouch cells hitting 323 Wh/kg. A solid mid-tier contender. ProLogium, Taiwan. A fascinating approach. They temporarily fluidize ceramic electrolyte during production, allowing it to flow into micro-crevices before cooling back into a solid. Their prototypes, 360 Wh/kg today, targeting 470 Wh/kg soon. Gigafactory planned in Dunkirk, France for 2027. SK on South Korea opened a large pilot plant in 2025, targeting 800 Wh/L volumetric density, likely around 280 to 300 Wh/kg. Commercial timeframe, 2029. So, when will we finally see solid-state EV batteries? Nearly every major player, Europe, China, the US, Japan, is landing on the same year, 2027. Will that be the magic year? Maybe, maybe not. But one thing is clear. For the first time in a decade, multiple companies have pilot lines running, real prototypes working, and serious manufacturing efforts underway. The pieces are falling into place. So yes, solid-state batteries are coming. And yes, they're coming soon. But not tomorrow, not next month, and not in the next model year vehicle brochure. We're close, but we have to stay patient. If you enjoyed this deep dive, make sure to like the video, subscribe, and comment Solid State 2027 to let me know you were here. Thank you for watching. Have a great week. And as always, Just have a think.